Okay. So I think, Hmm. yeah. So what we have done is, Hmm. So we are worked with NumPy. So in this, yesterday we have seen like how to work with this append, insert, and replacing values. Okay, right? So yesterday we have seen how to replace the values. So I said how to replace one value and how to replace more than one value. So here, replacing one value, you can do it by using index. And if you want to replace multiple values, you can use what here? Slicing, right? So this is how updation is done. But see here, array is a mutable, but only one mutable operation you can do it, and that is what? Update. But you have an append insert, but this append and insert, after appending or after inserting, the result is written into what? New array. So the changes are not done in the same array. The changes are done in what? New array, right? Then next we'll see, how to work with the, progressive operations. Okay. So progressive operations, or how to work with the, what do you call it, as cumulative operations. So when you're working with arrays, yeah, you may do this progressive operations or cumulative operations. Matrix is there. Yeah, we'll see that. We'll see that also after this. Progressive operations or cumulative operations. So here you have some operations which can be done on series of values or cumulative operations. So this can be called as a cumulative operations. So cumulative operations you find here. So what are these cumulative operations you find is, let me tell you this first. Just check the, so cumulative operations. Now here you have some aggregate operations like sum. There is an aggregate operation called sum, and there is an aggregate operation called max. There is an aggregate operation called min, and you find an aggregate operation called product. In the same way, you can also find a cumulative sum. So there is a cumulative sum, and there is a cumulative max, and there is a cumulative min, and there is a cumulative product. So these are cumulative. For every aggregate, So there is equivalent cumulative operations, right? So there is a sum and you have a cumulative sum and there is a maximum and there is a cumulative maximum and there's a minimum and cumulative minimum and the product and you find a cumulative product. So these are the operations here. So these are called which operations here? Cumulative operations. So in this, the first operation already we have seen called sum. For example, if you see sum here, I'm writing import numpy. So for example, there is an array. So there is an array that is numpy dot array with some elements. So this is an array with how many values? 5 values. So you have an array with how many values here? 5 values are there. So that is 10, 20, 30, 40, 50. What will happen if I'm saying np dot sum? Np dot sum A. So it will try to add all the values. It will try to add all the values and return the total. So what is the sum of this 10, 20, 30, 40, 50, 150? But what will happen if I'm writing a cumulative sum? So cumulative sum, I'm using a cumulative sum. And here I'm writing the array. So what is the name of the array is A. So when I say yes, if I'm writing this and if I say print result 2, so cumulative means now it will take progressive. Progressive means now it will take 10 and 10 plus 20. Now initially it starts with total starts with 0. What is initially sum is 0. So progressive means it will take sequentially now 0 plus 10 becomes what? 10. And 10 plus 20 is what here? 30. And 30 plus 30 is what here? 60. And 60 plus 40 is what here? 100. 100 plus 50 is what here? 150. Now this you can call it as which is some cumulative sum. Okay. So it is like the way how you are generating progressive values by using a range. In the same way, you are generating a cumulative sum. Okay, by using a function called which one? cum sum, cumulative sum. Now this can be done. Okay, this can be done on the array. Now what is the syntax of this is? I'm taking syntax from here. What is the syntax of this is? This is cumulative sum. Already I said about sum, right? So the first function is, now I'm not telling the sum because already we have seen sum, minimum, maximum. Already I said about this, but I'm telling you only cumulative operations. So numpy dot cumulative sum is a function in the numpy library in Python that calculates the cumulative sum of elements along given axis, or what is it? Array. So what it returns is, see here, it returns a new array. It returns a new array where each element is a sum of all preceding elements, including itself. It returns a new array where each element is a sum of all preceding elements. It returns a new array where each element is a sum of all preceding elements, including itself. along with the specified access. Along with the specified access that is done by a function called this. So what is the syntax of this? Actually, it will convert this into 1D array. See, whenever you give this, right, it will convert into 1D array. It is having parameters. And what is the syntax is, you'll say numpy dot cumulative sum, and you give an array, and there is what here? Access. So initially access is what here? None. Now you can give the access 0 and access 1. So if the access is none, okay, if you say access none, see here, if you say access none, okay, if you say access none, what will happen is, it will try to convert. If access is none, if access is none, it produces a cumulative sum. It produces the cumulative sum. It produces cumulative sum on 1D array. Means even though if you give the input as 2D array, it will convert into which array? Flattened array. Okay, it will convert into flattened array or flattened array. That is nothing but 1D array, it will convert it. When if you are giving access is what here? None. When the access is none, it produces cumulative sum on 1D array. Even though if you give the input as a 2D array, it will convert that into which array? 1D array. See here, for example, if I am creating one more array, means this is 2D array or matrix. I created matrix 1, 2, 3. So 1, 2, 3, 4, 5, 6. Now this is a matrix, and this is a matrix which contains 2 rows and 3 columns. This is a matrix which contains 2 rows and 3 columns. Now you want to do some cumulative sum. Okay, I'm writing a result 3 equal to np dot cumulative sum on B. So cumulative sum on B, but what is the default access is? None. If the default access is none, what will happen? This is 2D array. So this is 2D array with 2 rows and 3 columns. It is a 2D array with 3 rows and 2 columns here. So that is 1, 2, 3, 4, 5, 6. So what will happen if the access is none? It will convert this. It will convert this 2D array into what here? 1D array. So that is nothing but 1, and there is a 2 and 3, 4. So there is a 5 and one more is a 6. Then it will produce a cumulative sum. Then it produces a cumulative sum by taking the number itself. What is the number itself here? 1. And you can see 1 plus 2 is a 3. Progressive sum. Now 3 plus 3 is what here? 6. And 6 plus 4 is what here? 10. And 10 plus 5 is a 15. And 15 plus 6 is what here? 21. So this is, if you give the access is what here? None. So again, the result is written as which array? 1D array. What is the result is written? 1D array is written, right? So that is when you give the access is what? None. Suppose I try to give the access np dot cumulative sum. Okay, I'm trying to give the access. Now what is the name of the array? B. And I'm writing here access 0. Here I'm writing access 0. And if you are trying to print a result 4. Now you are trying to do cumulative sum on access 0. So this is the matrix here. This is a matrix which contain 3 rows and 3 columns. So this is 1, and there is a 2, and there is a 3. So 4, 5 and one more is a 6. So what happened here? What is the result is? The result of this is, what is the result is? The result is, it is displayed like this, right? What is the result? You can see 1. So there is 1, right? And there is a 2 and there is what here? 3. And after that here you have a 5 and this is 7 and this is what here? 9. So it is nothing but 1 plus 4. 1 plus 4 is what here? 5. And 2 plus 5 is what here? 7. And 3 plus 6 is what here? 9. Means here, axis 0 means what it is doing? It is doing the cumulative sum on which one? Columns, right? Column. That is axis 0. When you are writing it as axis 0. I'm writing a result 5 equal to NP dot cumulative sum. Cumulative sum B, and here I'm writing axis 1. When I'm writing axis 1, this is nothing but along with the rows. It will do the cumulative sum along with the rows here. So this is a 2 rows and 3 columns. It is having 2 rows and 2 rows and 3 columns. And you are doing cumulative sum along with the rows. Rows is nothing but, now what is the result of this is 1, 3, 6, 4, 9, 15. So this is 1, 3, 6 and 4, 9, 15. It's nothing but 0 plus 1 is 1 and 1 plus 2 is what here? 3 and 3 plus 3 is 6 and 4 then element itself and 4 plus 9 is 9 and 9 plus 6 is what here? 15. So this is along with the rows. And if you want to do cumulative sum along with the columns, you are writing axis 0. If you want to do the cumulative sum along with the rows, you are writing what here? Axis 1. So that is axis 0 and one more is what? Axis 1, right? So this is sum. Now you can do with any dimension. So that can be a 2-dimension or 3-dimension or n dimension. So this is cumulative sum. So the way how you are doing the cumulative sum, in the same way, you can have a cumulative maximum and cumulative minimum and cumulative what? Product. So there is a function, and what is the name of the function is NP dot cumulative product. So this is cumulative product. So product means now it will do the multiplying. It will do the multiplying. So there is a cumulative product. So this functionality is also same. But instead of doing sum, it will do what? Product. Instead of doing sum, it will do what here? Product. So NP dot cumulative product function computes a new array where each element is a product of all preceding elements. Each element is a product of all preceding elements. Okay, right? So the product of all preceding elements. And what is the syntax of this is numpy dot cumulative product. You just give the array along with the access. And what is the default access is none. Means it will convert into 1D array and perform operations. It will convert into 1D array and perform the operations. NP dot, I'm creating an array. Suppose I'm creating an array np dot random integer. I want to generate from 10 to some 20. I want to generate some 5 values. Now here I'm creating an array with some random values. Now this is which array? 1D array, right? This is 1D array with how many values here? 5 values. Now I want to have a cumulative product. Okay, we'll have some 1 to 10. Okay, because multiplying, right? Okay. So what I'm doing is result 1. Okay, result 1. So equal to np dot. Now you are using a cumulative product. And what is the name of the array is A. This is cumulative product and A. And what will happen if I print? Now you can see 1 and 1 into 3 is a 3 and 3 into 3 is a 9 and 3 into 9 is 27 and 27 into 2 is what? 54. Now it's trying to do the cumulative product or not? Yes. Now result 2, now I try to create another array by saying np dot random integer. I am creating some random values from 1 to 10. I want to generate 6 values and I want to convert this into 2 by 3 matrix. I want to convert this into 2 by 3 matrix. It's nothing but a 2 rows and how many columns here? 3 columns. Now it is created one random matrix. I mean, this is a matrix which is having 2 rows and how many columns here? 3 columns. Now if I'm writing a result 2 equal to np dot cumulative product. np dot cumulative product and there is a B, but I have not given access. If you don't give the access, it will convert this 2D array into what? 1D array. If you don't give the access, it will convert this 2D array into 1D array. You can see this is the matrix with 2, 1, 1 and 7, 6, 8. So it will convert this 2D array into 1D array. Means now this is 2, 1, 1, 7, 6, 8. Now it will do the cumulative product. Now the element itself and 2 into 1 is a 2 and 2 into 1 is a 2 and this is 14 and 14 into 6 is 84 into 8 is 672. So if you are not giving the access or if the access is what here? None. If you are not giving the access or if the access is none, it will convert any array, it will convert into which array? 1D array. If it is 2D array, it converts into 1D array. If it is 3D array, it converts into what? 1D array. So that is done by the function called which one? Cumulative product. So I'm writing a result 3 equal to np dot random. If you want to write along with the access, now result 3 equal to np dot cumulative product. Cumulative product b comma access 0. Access 0 is nothing but along with the column. along with the column. If I'm saying NP dot, okay, NP dot cumulative product, if I'm writing a B comma axis 1, this is nothing but along with the rows. One is along with the rows and one more is along with the columns. Axis 0 is nothing but columns. Okay. So axis 0 is nothing but column. Now you can see 8 into 1 is 8 and 7 into 1 is a 7 and 6 into 6 is what here? 36. But is it first row is changed or unchanged? Unchanged. It means what it is doing actually it is multiplying with what here? 1 or it element itself. This is nothing but element itself. This is nothing but element itself. It means first row element itself means 8. 8 is written 8, 7 is written 7, 6 is written what? 6. Now this row first column is multiplied with what? First column in the second matrix. I mean second array, right? Yes, that is row and one more is a column. So axis 0 is nothing but column and axis 1 is nothing but row. So the way how you are doing the cumulative product, see product returns the complete. If I am writing a result 5 equal to NP dot product, NP dot product A means it will multiply all the values with initial value as 1. With initial value as 1, you can see 72 means it is multiply all the elements. It is multiplied all the elements 1 into 2 into 4 into 3 into what? 3. And what is the product of these elements is 72. You can just use a product or you can go for which one? Cumulative product. Okay. So this is done by using the function. So this both the functions differences you have to find out. Okay. So product and cumulative product. In the same way, the way how you are using a cumulative product, in the same way, you can find the cumulative minimum. You can find the cumulative what? Maximum. So maximum returns a maximum value. Maximum returns what here? Maximum value. Okay, but cumulative maximum, it compares the elements and return the maximum value. It compares the elements and then returns the maximum value. So that is a cumulative. Cumulative, what is it? Maximum. This is cumulative maximum. Means you are comparing the elements and returning a progression by using maximum, right? Now how? What is the differentiation is the same. Cumulative, what is the name of the function is max. So the term cumulative max doesn't directly refers to a function within the core NumPy library. So it just uses the library which belongs to which one? Pandas. It means these functions you find even in which one? Pandas. Because Pandas internally uses what? NumPy for representing which one? Data. Pandas internally uses NumPy. Like you have a series. Series is nothing but 1D array. Data frame is nothing but what? 2D array, right? So NumPy provides the data structures like two. One is series and one more is a data frame. And series represents what? 1D array. And data frame represents what? 2D array. So internally, Pandas is built on the top of which one? NumPy, right? So that is what you have to understand here. But what will happen here is cumulative sum, it will do the same thing. Cumulative maximum values, it returns the cumulative maximum values along with the specified access. Along with the specified access. And what is the syntax of this is, you are writing NumPy dot cumulative maximum and write the array and define what here? Access. And here default access is what? None. So you can also give the access 0 or you can give the access 1. Now this is comparing the values. Now you take an array np dot array. You create a random array. So random dot random integer. I'm generating the values from 10 to 20. I want to generate some 5 samples. Okay. So this is 1D array. So this is 1D array, right? Now I want to find out the maximum. If I want to find out the maximum value, how can I find out the maximum value? By using a function called max. Now that will return the maximum value. If I'm saying this is a maximum value, so that is written the maximum value. And what is the maximum value is 18. In the same way, I want to find out the cumulative maximum values. Cumulative maximum values, then I'm writing np dot cumulative maximum a. So this returns the cumulative maximum values. So by comparing elements, so cumulative maximum values, if you see this cumulative maximum values, you have to, this one, right? Actually, this one you have to import. Yes. Now module NumPy has no attribute. What it is saying, it is no attribute called which one? Cumulative maximum. So it means now if you want to do this cumulative maximum, so we have to import pandas, right? That is a problem here. Cumulative maximum. So what will happen here is you want to find out the cumulative maximum. What do you do is now import. I'm trying to import pandas. I'm trying to import pandas, and what I'm doing is I'm converting this array. Now this is array, right? I'm converting this array into one more data structure called a series. It is also one-dimensional array in pandas. Series of what is that here? A. Means what we are trying to do, we are converting this array into what here? Series. Series is also 1D array, but differences will see once we move to the pandas. Now I'm writing here not NP. I'm writing which one? Pandas. Pandas dot what is that? Cumulative maximum of which one? S. S is what now? Series. S is a series. Now you can see maximum. Oh, sir, this is S dot. It is an attribute or it is a method. Cumulative maximum. Cumulative maximum. I've written S dot. S is what now? Series. And cumulative maximum is what? Method. It is a method. Now you can see it is written the values like this. What is the values it is written? Cumulative maximum values it is written. So what is the values it is written? 17. But actually, what is the series? Well, print S here. A. What is this here? So actually, now when you are working with a series, right? Series. So when you are working with a series by using cumulative maximum, it will do the cumulative maximum along with what access. Now you can see, now first one is 16 itself. And then it is comparing 16 with what again? Or it is comparing 16 with what here? 12. And is it 16 is greater than 12? Yes. Then what is the next value is 16? Again, 16 is compared with what here? 18. And is it 16 is greater than 18? No. So what is the maximum value is 18? And 18 is compared with again what? 16. And is it 18 is greater than 16? Yes. It is written the value. And next value is 18. And 18 is compared with what? 17. Is it 18 is greater than 17? Yes. Now it is comparing the. Now for this, you have to convert. See here. For this, you have to convert this array into what here? Series. Because this cumulative maximum is a method of which one? Pandas. Pandas, which data structure? Series. And one more is a data frame. So what you are trying to do is, you are trying to convert this array. You are trying to convert this array into what? Series. And series is also 1D array. Series is also 1D array, but some differences are there that we'll discuss. So series is also 1D array, and you are converting this 1D array into what? Series. And then you are calculating what here? Cumulative maximum. Okay. So cumulative maximum, if you want to find out using a NumPy array, you have to convert this NumPy array into what? Series. You are converting this NumPy array into what? Series. But how you are converting it? By using a type called which one? Series. Right? But you cannot do it directly because there is no method called cumulative max belongs to what? NumPy. So here I need to do changes here. What is that here? Uh, I write here cumulative maximum because it is an attribute. It is an attribute or it is a method. It is a method of series or what is that? Data frame. It is not a function. It is a method. Method means it is a member of a type. If it is a member of a type, it is called as what here? Method. See here. S dot. S dot. Dot is called which operator? Member access operator. Dot is which operator? Member access operator. Now S is nothing but what here? Series. Okay. Object. This is an object and you are finding the cumulative maximum. In the same way, if you want to find out the cumulative maximum on 2D array, you want to find out the cumulative maximum on which array? 2D array. Then you convert this 2D array into data frame. You convert this 2D array into what? Data frame, and you find the cumulative maximum. But you cannot do it directly here. You have to convert that into which type? Series. And series is also 1D array. Series is also what here? 1D array. Now the way how you are finding the cumulative maximum, in the same way, you can find out what? Cumulative, cumulative what? Minimum. So this will return the minimum value along with the access. So that is done by using cumulative minimum. So you are finding the minimum value, you are finding the maximum values along with the given access. But if you don't give the access, anyway, it is take by default what? 1D, right? So this is a cumulative minimum. Cumulative minimum calculates a minimum value. It calculates the minimum values along with the access. I can write the same thing. So that is nothing but minimum and one more is a maximum. So same example. Now this takes minimum value and this will take which value? Yes, minimum value along with the access. Now you can see I changed this to minimum. So what it returns the minimum values. So first one is 18 itself and 16, 12, 12 and one more is a 10. So this is a minimum. So there is a maximum value and there is a minimum value. Output also I have to write a, okay. So this is output of minimum. Yeah, okay. Maximum output, no problem. You write it. See here, these are, now see, so these are cumulative operations, right? So this is cumulative sum, cumulative maximum, cumulative minimum, cumulative product, and you have a cumulative sub. Okay, that is nothing but subtraction. So cumulative subtraction also there, but I've written some frequently used like cumulative sum, cumulative maximum, cumulative minimum, and cumulative product, right? So then next we'll see performing. So performing some matrix operations. So performing some matrix operations. Yes. So NumPy, I said no, NumPy is having a lot of functions. So many functions you find in what? NumPy library. Okay. Because whenever you talk about numerical analysis, you find a lot of things belongs to this, right? So when you're talking about vectors as well as what? Matrices, you do a lot of operations. Now vector is nothing but 1D and now matrix is nothing but what? 2D. Now you want to perform some matrix operations. For that, NumPy provide one type called matrix. NumPy provide one type called which one? Matrix. There is one type. Actually, that is deprecated, but even still, some people are using it. So what is the name of the type is matrix. So NumPy uses matrix. So there is a NumPy dot matrix and NumPy dot what is that? Array. So matrix is a type. Matrix is a type or matrix is what here? Function. Some people say matrix is a type, but some people say matrix is what? Function. But matrix is a type or function. What it returns? A matrix with a given rows and what is that? Columns. Now instead of using a function array, directly you can use a function called which one? Matrix. Now yes, a NumPy is a fundamental. Okay, no problem. So there is a function. What is the name of the function is? Yes, here. What is the name of the type is? What is the name of the type? Matrix. Matrix is a type, but it is a legacy. Legacy means it has been used in which versions? Previous versions are older versions. It has been used in previous versions or what? Older versions. Because of that, it is called as which class? Legacy class. So what is the name of the data type here? Matrix. The name of the data type is matrix and it is a subclass of which one? ND array. It is a subclass of ND array. So there is a type. What is the name of the type here? Matrix. What is the name of the type here? Matrix. Matrix is a type or matrix is what? Class. What will happen if I'm using this matrix class in the current versions? You may get a warning. If I'm using a matrix in the current version, you may get a warning, right? You may get a warning saying that, okay, you cannot use this because it has been not used in what coming version like that. You will get a warning. Otherwise, you can use directly a function called which one? Matrix, right? So by using which you can perform some matrix operations. Generally, if you want to create a matrix, how you create a matrix? By using an array function only, right? Suppose I want to create a matrix. I want to create a matrix. What will I do? I'll say matrix 1 equal to np dot array. np dot array, I'm saying 1, 2, 3, comma 4, 5, 6. Now this is This is a matrix with 2 rows and what? 3 columns. And here I'm writing matrix 2 equal to np dot array. Okay, I'm creating another matrix. Here I'm writing something, some 3, 4, 5, 3, 4, 5, 7, 8, 9. Now this is one more matrix with again 2 rows and how many columns? 3 columns. This is a matrix 1 and this is what here? Matrix 2. Now if you run this, now you can see this is a matrix 1 and this is a matrix 2. But matrix 1 and matrix 2 is of which type? Matrix 1 and matrix 2 is of which type? ND array. If I'm saying type of matrix 1 and type of matrix 2, it is of which type? ND array. It is of which type? ND array. But I can also use one type. What is the name of the type? What is the name of the type? Matrix. I can also create a matrix by using a type called which one? Matrix. I can create it. I can create it by using one type called matrix or a function called which one? Matrix. But it is a constructor. Is a constructor calling. That is which calling? Constructor calling np dot matrix. So there is a numpy dot matrix. Numpy dot matrix. Here, this is a matrix and matrix with the data and matrix with what here? Data type, and here also have which one? Copy. What is the name of the class here? Matrix is a data type. So returns a matrix from an array like object or from string of data. See here, there are two things are there here. So returns a matrix from array like object or from a string of what? Data. Means you can convert a string into a matrix even by using which data type? Matrix data type. See here. So what is the name of the class? I take the syntax here. So this is a syntax of it. Now class numpy dot matrix, and here you are writing a data and data type and copy equal to what here? True. We'll discuss this. What is the meaning of copy equal to true? Okay. But data is which type? Data can be which type here? Array type. Or a data can be of which type? String. Here data can be of which type? Array. Here data can be of which type? String. It means I can convert a string into which one? Matrix. I can convert an array into what here? Matrix by using which data type? Matrix. And you can also define the data type. Right? Let me tell you about this, like how exactly it will work. Now this is a syntax. This is a syntax. This is a syntax of using this, right? Yes. Now this is data. Data can be array like object or it can be what? String. It can be array like object or it is what? String. And you can define the data type, and copy is a Boolean value. So that is that value can be either true or false. Let me tell you about this. So how to create this? I'm saying here matrix 1. Now, previously we tried to create an array or matrix by using which function? Array function, and that returns which object? ND array object. Now you can create a matrix. For example, here I'm creating an array. A is there. Okay, I just take this same array. This is matrix 1, right? This is a matrix 1 here. Matrix 1. Matrix 1 is ND array object. It is which object? ND array object. I'm saying matrix 2 equal to NP dot matrix. I'm saying NP dot matrix. And I'm trying to use a data. What is the data I'm using here? Matrix 1. Because what is the data? Data should be of which type? See here, data should be of which type? Array or string. This data is which type now? Alright, this data is which type now? Array type. Okay, this data is array type. If I'm saying print print matrix 1 and I'm saying print what is this here? Matrix 2. I said print matrix 1 and matrix 2. Now you can see both are matrices only. But type, see the type. If I'm saying type of, matrix 1, if I'm saying type of matrix 1 and type of matrix 2, matrix 1 is of which type? ND array. Matrix 2 is of which type? Matrix. Now, when you convert into a matrix, you can perform all matrix related what? Operations. Because it is a subtype. Okay, matrix is a subtype of which one? ND array. Means it is having all the methods of what? ND array, but is having its own methods. Because you'll say no subclass, parent class, and child class. Now, child inherit all the properties and behavior of which class? Parent class. Now, whatever methods are there in ND array, all the methods you find in what? Matrix. With some extra functionality belongs to what? Matrix. Getting or not? Okay. Now here, so here what will happen is, now this is creating a matrix using which object? Array object. But I want to create a matrix by using which object? String. I want to create a matrix by using which object? String. Now I am writing here matrix 3, np dot matrix. np dot matrix. Now I have to represent what? String. I have to represent a string. Suppose I'm writing a string like this. String. Now, when you are saying string, the string contains the values, but I need to represent the data in the form of rows and columns. How you represent data in rows and columns? There should be some separator or not? Yes. There should be some separator. What is the separator? It uses comma here. What is the separator it uses is, now this is array objects here. What is the separator? Now here, within the single quotes or double quotes, whatever you write, it is called as which one? String. Now what is the separator used here? Semicolon. Sorry, what is the separator it is used here? Semicolon. Semicolon means, now that semicolon represent a separation of what? Row. Now you want to convert. Suppose 1 space 2 space 3 semicolon. I'm saying 4 space 5 space, what is that? 6. It means I'm creating a matrix with how many rows? 2 rows. And how many columns here? 3 columns. But what is the row separator used here? Semicolon. Now this is the first row and this is what here? Second row. This is the first row and this is what here? Second row. Now you can perform all matrix related operations. What operations you can do? What are the operations you can do? Almost all the operations what you learn as a part of your mathematics, you can apply all those operations on what? Matrices. Okay, adding, subtracting, multiplying. Okay, so dot product, inverse, transpose, everything you can do it by converting this or by representing this data in the form of which one? Matrix. So let us talk about how you can perform these operations on matrix. Okay, you understood this, how you create a matrix. Now there is one parameter is there. What is the name of this parameter here? Copy. So there is one parameter here, copy is there. So what is the value of this copy here? True. Copy is a true. So if the copies are true, what will happen? Just see here. You can also define the data type. So what is the default copy is here? True. Now I'm saying matrix 1. I'm saying here matrix 1 and there is a matrix 2. So it is written. Now what I'm doing is I'm trying to do changes in matrix 1 because we populated this data, right? This data is used by which one? Alright, this data is used by which one? Matrix 2. Suppose if I'm trying to do changes in matrix 1, I'm saying matrix 1 of 0, 0. Matrix 1 of 0, 0 equal to 99. I said matrix 1 of 0, 0 equal to what? 99. Means I do changes in what here? Matrix 1. I think you know copy, right? How many types of copies are there? Two types. One is deep copy and one more is what? Shallow copy. Yes or no? One is a deep copy and one more is what? Shallow copy. What will happen in shallow copy? Shallow copy is which copy? Reference copy. It means if changes are done in one, that reflect to what? Another, right? But in deep copy, will it create a copy of the elements or not? Yes. But now here, copies are true. Now let us see here. Let us now here when I say matrix 2, is it any changes are done in matrix 2 here? No. So the matrix 2 is written same or not? 1, 2, 3, 4, 5, 6. Now what I'm doing is I'm writing a matrix 3 equal to np dot matrix, np dot matrix. Okay, np dot matrix. See here, the changes are not done. Okay, matrix 3 I created, but changes are done in matrix 1, right? I'm creating np dot matrix. I'm creating np dot matrix. What is the name of the matrix is matrix 1, and here I'm saying copy. Copy equal to what here? False. I said here copy equal to false. When I say copy is a false, now what will happen? See here. So print matrix 3. Now it is created matrix with the values of which one? Matrix 1. It is created matrix with the values of which one? Matrix 1. Okay, 1, 2, 3, 4, 5, 6. Now, what I am doing is, I am trying to do changes in matrix 1 by saying matrix 1 of 0, 0 equal to 99. If I say matrix 1 of 0, 0 equal to 99, and when I print a matrix, matrix 3, what will happen when I print a matrix 3? Is it changes are done in matrix 3 or not? Yes. If you say copy equal to false, it will do which copy? Shallow copy. If you say copy equal to true, it will do which copy? Deep copy. Means it will create another copy. It will create what? Another copy of the object. But when it comes to copy equal to false, is it creating another copy? Na? No. So what it is it referring to the same object or different object? Same object. That is what will happen when you work with the shallow copy. Now, when you're writing a copy equal to false, it will do which copy? Shallow copy. So what will happen in this case? If you do changes in matrix 1, if you do changes in what? Matrix 1, that changes will reflect to what? Matrix 3. See here, I do changes in matrix 1. I replace the first element. What is the index of first element? 0, 0. This element I replace with what? 99. Then is it that changes are reflect to the matrix 3 or not? Yes. When if the value of copy is a false. But by default, the value of copy is what? True. Means it will do which copy? Deep copy. In deep copy, another copy is created. Another copy of the object is what? Created. But in shallow copy, another copy of object is not created. Right? So just try to understand this. This is about copy. But what is the default value of copy? True or false? For true. What is the default value of copy? True. If copy is a true, see here, I'm just writing here. If the copy is a true, it will do which copy? Deep copy. Means changes in original matrix doesn't reflect to copy. Doesn't reflect to copy. But if I'm saying copy equal to false. Copy equal to false, it will do which copy? Shallow copy. In shallow copy, if you do changes in original, that reflects to what? Copy. Because we are creating a matrix by using the data of which one? Matrix 1. Getting or not, right? So this is about copy is true and copy is what here? False. If you want to do that kind of changes, like originally if you do changes and if you want to do that changes on copy, then just go for copy equal to what? Copy equal to what? False. Otherwise, that changes will not be done, right? Yeah, I think you understood this is how you create a matrix by using data and copy, and you can also define what? Data type. Data type also you can define. So data type also you can define here, data type. So while creating matrix here, this is a matrix I'm creating, but this is a matrix of which type? Integer. Now I'm writing here matrix 2 equal to np dot matrix of which one? Matrix 1, comma, I'm writing here data type np dot, what is that? Float. Float what? 32. 32 means how many bytes? How many bytes here? 4 bytes. 32 bits are 4 bytes. So matrix 1 and one more is a matrix 2. You can see it is converted this integer to what? Converted this integer to what here? Float. 1.0, 2.0, 3.0, 4.0, 5.0, and what is that? 6.0, right? Yes, this is D type. So D type attribute represent or parameter. So D type parameter represents what it represents? Data type of array elements. But what is the default data type it takes? The data type of what? Elements only, right? Yes. So this is a example of this. I converted the type from integer to what? Float. But you can convert into any type. We converted integer to float, but you can convert into what? Any type you can convert it. Okay. Now this is creating a matrix by using which data type? Matrix. So once the matrix is created, what you can do? You can perform operations. Once the matrix is created, what you can do? You can perform operations. You can perform operations. What operations you can perform? What operations you can perform? Arithmetic operations. Arithmetic operations you can perform on which one? Matrix. So this is arithmetic operations. Aggregate operations, arithmetic operations, aggregate operations. Okay. And matrix operations, all this you can perform it by using which object here? Matrix object. All these operations you can do it by using which object? Matrix object. Yes. You find lot of attributes. If you want to see the attributes of this matrix, right? You can see matrix dot. If you see the attributes or methods of this, so there are a lot of methods belongs to this methods. Now, if you see methods of this, you can see argument maximum, argument minimum, see here, argument partition, argument sort, and byte swap, choose, and clip, see here, compress, conjugative, right? Copy, cumulative product, cumulative sum, diagonal, dump, dumps, fill, flatten. Okay, get A1, get horizontal, inverse, right? So see, all these are maximum, mean, minimum, non-zeros, partitions here. All these are the methods of which one? Matrix. See, you are not saying NP dot. Previously, you are trying to use what? NP dot sum. Sum is a function, but here sum is a function or method? Method. Sum is not a function. Sum is what here? Method. See here, cumulative product, cumulative sum, cumulative product, cumulative sum, and if you want to sort it, you can sort it. Now there is argument maximum, there is argument which one? Minimum, right? So let me tell you all these methods, but before that, we just see which operations? Arithmetic operations, which we did already, but I'm telling you again, right? Yes. Now, what you have to do is you have to create a two matrices. So I just take a matrix. I create a matrix. So there is a matrix 1, np dot matrix. I'm creating a matrix using a string 1, 2, 3, semicolon 4, 5, 6. Space you have to give 4, 5, 6. So this is a 2 rows and 3 columns. And there is another matrix np dot matrix. And there is a 4, 5, 6 space. Give the space 4, 5, 6 and semicolon. I'm writing here 7, 8, 9. Now I converted string into what here? Matrix. So this is a matrix 1 and there is what here? Matrix 2. Now when you run this, now this is matrix 1 with 2 rows and 2 columns. And this is a matrix 2 with again 2 rows and 3 columns. Now you can do all arithmetic. Matrix 3 equal to matrix 1. Matrix 1 plus what? Matrix 2. This is nothing but adding what? 2 matrices. This is nothing but adding 2 matrices. Now you can see this is adding 2 matrices. Element wise 1 plus 4 is 5 and 2 plus 5 is a 7 and 3 plus 6 is a 9 and 4 plus 7 is 11 and 5 plus 8 is 13 and 6 plus 9 is what? 15. This is adding 2 matrices. Okay, you can do it by using which one? Plus. So matrix 2 minus what is that? Matrix 1. Now this is subtracting matrices. So this you are doing it element wise. It will do this what? Element wise. Now if you run this, you can see 3. It's nothing but 4 minus 1. 4 minus 1 is what? 3. 5 minus 2 is what again? 3. And 6 minus 3 is what again? 3. And 7 minus 4 is a 3. And 8 minus 5 is a 3. And 9 minus 6 is what again? 3. In the same way, you are writing a matrix 5. So matrix 5 equal to matrix 1 into what is that? Matrix 2. Is it do the dot product? No, it just multiply the elements. It will multiply. See here. So it is, what is the shape? Shape is the same or different? We changed it. So here I just write. So if you are writing your star, what star is doing? Here it is giving right error. What is error is? So it is multiplying, right? When you are trying to find the dot product. So what is the rule for multiplying 2 matrices? What is the rule for multiplying 2 matrices? Number of rows in first matrix should be equal to number of columns in what? Second matrix. But is it same? No. Then immediately it is given which error? Value error. Is it doing a dot product or not? Yes. Then what I have to do? I have to create another matrix, right? So create another matrix for doing product. You can also use star. You can also use a method called dot. Let me create 2 more matrices because the shape is not same. M1 equal to NP dot matrix. So I'm just creating a simple matrix with 1, 2 and 3, 4. Okay. 1, 2, 3, 4. Matrix 2 equal to NP dot. What is this again? Matrix with some 2 space 3 semicolon and here I'm saying 4 and then one more is a 5. So now this is 2 by 2 matrix. Now this is 2 by 2 matrix. Now this is a matrix with 2 rows and 2 columns. And this is a matrix with again same 1, 2, 3, 4. And this is what? 1, 2, 3, 4. And this is 2, 3, 4, 5. Now you are doing what here? Multiplying. What do you do it? 1 into 2 plus 1 into 2 plus 2 into 2 into 4. Then 1 into 3 plus 2 into what is that? 5. 3 into 2 plus 4 into 4. Then 3 into 3 plus, okay, 3 into 5. So this is a product of this two matrices or not? Yes. Okay. Now just to run this. M3 equal to M1 into what is that? M2. But the rule you have to remember. Okay, M1, M2, and one more is M3, right? So if you run this, you can see 10, 13, 22, and one more is a 29. Okay, so that is 1 into 2 plus 2 into what is that? 4, yes. So this is nothing but 2 plus 8 is what? 10, right? So this is how it is doing which one? Multiplying. So multiplying is nothing but dot product. This can be done. This is nothing but which one? Dot product, right? Yes. Now you can do other operations like all arithmetic operations can be applied. You can apply plus, minus. Now I'm writing here matrix 5, matrix 5 equal to matrix 1. What is that slash? Matrix 1 slash matrix 2. Matrix 1 slash matrix 2. If you run this, you can see is it done division of elements? So element wise vectorized operations means 1 divided with 4. And what is the result of this is 0.25 element wise. This is element wise. Now 2 with the 5. What is the result of this is 0.4. So division you can also do. Now these are vector operations means element wise it will do it. If I am writing a matrix 2, now I am writing a matrix to the power of matrix 1 power exponent, right? So if I am writing here matrix 6, what will happen here? It is written the elements. What is that elements? Not integer. Power n. Matrix 2, matrix 1. What is this shape of this is? 1 minute. So it should be a square matrix, but here, so it is given error. So what is the error is here? Last 2 dimensions of the array must be square. But is it a square matrix? No. So it is having 2 rows and 3 columns. And this is also having 2 rows and 3 columns. Then we'll take this one, right? What is that? M1 and M2. Just take M1 and M2. M3 equal to M1 to the power of M1 equal to M3 equal to M1 to the power of M2. It is not integer. What happened here? What is M1? M1 is integer only, right? Just take the type. It must be, see, if you want to do the exponent, it should be what? Square matrix. It must be which matrix? Square matrix. Okay, just to see it. I'll create another matrix just here. M4 equal to NP dot matrix. I said matrix. So here I'm writing 1, 2 and 3 and one more is what? 4. So M5 equal to M4 into or M4 to the power of, okay, I'm writing like this, to the power of 2. Now this 2 is which value? Scalar value. This 2 is which value? Scalar value, not string. Or we converted into matrix. We converted, right? It is a matrix here. Okay, not a string. We converted into matrix. Now I take a scalar value. See here. Just see here. M4 is a 2 by 2 matrix with a 2 rows and 2 columns. Now I try to raise each element to the power of which one? 2. Just see here. Print M5. Now each element is raised to the power of how much I've given? 2. So that is 1 to the power of what is the matrix is? M exponent. What is the matrix? M4. So what is my matrix is 1, 2, 3, 4.